All right. So thank you for inviting me to this event today. So as Sarah said, I'm Anja Thieme. I go by the pronouns of she, her. I have quite white freckled skin, dark blonde hair, tied into a bun, and I'm wearing a blue blouse today. And yeah, I'm a principal researcher in Microsoft Health Futures, and I, in general, study the design and implications of AI use within clinical practice, but I particularly focus on responsible AI design. But please don't expect me to have all the answers to the various questions I'm probably going to get raised today. I should also say I'm not a designer by background. I'm more formally trained as a human-computer interaction researcher. But there are a lot of design elements to the way that I work. So let's see. So the project I want to talk about today is called Project Talia, which has been a 3-year-long research collaboration between Microsoft and a company called SilverCloud Health. And together we kind of developed machine learning models that will predict patient outcomes from online CBT treatment. So just to give you a bit more context about SilverCloud. So SilverCloud is a company that provides human-supported cognitive behavioral therapy access predominantly for the treatment of anxiety, depression, and stress. And in the UK, a GP even can prescribe you access to SilverCloud for patients who might have mild and moderate symptoms of depression and anxiety, who then themselves have to work through the therapy content, however, in their own time. And so for the depression and anxiety online program, just to show you here, typically user gets access to 8 content modules. And then each module has a number of information pages that basically teach you the fundamentals of CBT treatment. And then within those embedded are sort of a set of tools that really help the person apply these learnings into practice. And as you can imagine, the more time and effort patients invest in the program and work with it, the more they tend to get out of it. But a key challenge often remains in keeping patients engaged and committed in the process. And so a really important element to help with that is that patients are supported throughout their treatment journey by a specifically trained human supporter. So that's somebody who regularly communicates with the patient, really helps them work through their difficulties and ensure an overall good patient experience. And obviously, these human supporters are really important in this context. So for us, it became quite relevant to ask the question of how machine learning insights could assist these ICBT supporters and maybe help them provide more effective, personalized care to their patients. And I should say that these supporters, to review patient progress and deliver their support, they use already a very specific intervention management side. And that includes this type of data dashboard for each patient. So you can see here, let me see if you can see my cursor. There's already lots of data insights that you have on how the person may have used, like have they logged in, how many content pages have they looked at, what exercises did they do, and so forth. And then in response to that information, what supporters do is they write feedback messages. And for that, they have, cursor's not very fast. I don't know, you probably can't see this, but they have like sort of templates available that they can adapt to the person to really effectively provide a highly personalized response. And what's also important is that this review configuration includes any kind of clinical questionnaire that the patient completes to assess their mental health symptoms over time. And that includes a clinical questionnaire called PHQ-9, that's for assessing depression symptoms, and the GAD-7 for anxiety symptoms. And patients enrolled in the program typically routinely collect responses to those questionnaires every week or bi-weekly. And so this routine data collection makes it basically a little bit more practically feasible to imagine how machine learning outputs might be generated and also fit into this data review configuration. And that's quite exciting because that presents like a huge opportunity to think about how we might move towards real-world integration of any AI applications within actual mental health practice, which is still fairly rare, I would say. And so to embrace that opportunity and still aiming to assist these ICBT supporters and improve their practice, our team specifically focused on the idea to predict patient outcomes early within treatment. And as is often the case, that choice is a combination of multiple factors. So for one, the idea stems a little bit from the clinical literature. So there is something called feedback-informed therapy, which basically suggests that if a clinician knows early on within treatment that their patient isn't on track to achieving the desired outcomes from treatment, then they can make necessary treatment adaptations to better meet that person's need. And so maybe they work harder to identify what the blockers might be, or maybe they move the person to a different treatment program. We've also done user research. We did an interview study with 15 ICBT supporters, where they also suggested actually understanding patients' mental health progression throughout treatment is really quite relevant. And of course, as I was saying, we had good data availability for the machine learning effort because there were these routine clinical questionnaires that were answered. And so I'm not going to go into the details of what is a recurrent neural network that's shown schematically on the slide, but basically what our team did is developed 2 binary prediction outcomes, one for predicting outcomes for depression and one for anxiety. And what happens here is that in order to train this machine learning model, we took 46,000 previous Silver Cloud users' symptom trajectories as input data to the model. That's what it trained on. And then as a result, we were able to predict for a new patient at every time in their treatment journey, what are the likely outputs going to be at the end in terms of whether they will have a reliable improvement in their depression or anxiety outcomes by the end of treatment. That's what the model does. And, you know, just for completeness, what happens is that our model was pretty good at predicting reliable improvements in depression, shown here to the left, and anxiety to the right. Our model is the dark blue line, respectively. The other lines are sort of baseline measures to show good performance. And good performance here is plotted at different time points. So once somebody has completed 3 questionnaires, which is time point 2 here on the plot, the models perform pretty good with 87% or better accuracy. Again, not to go into the technicalities, but what this suggested is, hey, we in principle can do a prediction of outcomes pretty early on within treatment. So great, we have these fairly robust prediction models, but then the more important question became how, if at all, is having such a data insight really useful to the work practices of ICBT supporters? You know, we wanted to kind of better understand what might be potential use cases around this, what would be the challenges for integrating such an insight within routine clinical care. And so to engage participants with these questions, what we did is we created a set of design mock-ups that illustrate different proposals for how AI predictions could be shown within the supporter user interface. I should say Marianne was part of the team, and also Maria Lyons from the Silver Cloud UX team worked with us on this. And the idea here for these 5 different mock-ups was that these visuals were very distinct, so they could show model outputs as part of an individual patient profile page, which is so the first 4 concepts, or show them for the entire patient cohort, which is sort of the dashboard feedback interface on the bottom right. But they also varied in how much context and explanation was given to an AI prediction, whether the outputs were shown more as a graphic, as text only, with or without percentage numbers of model confidence, and so forth. And so, yeah, the idea was to have different proposals to just understand how participants would evaluate them and what they would like about or dislike or be concerned about these various proposals. So I'm just going to touch on some of the learnings. So here we've got an example, the population comparison on the bottom left, where the prediction of one person is sort of shown to the very left. Let's see if I can get my cursor in here. So the prediction of whether somebody is over, so we have a patient prediction, and here it shows, oh, this person is likely to predicted to achieve a reliable improvement, both at depression and anxiety levels by the end of treatment. And then it basically shows how that compares to similar patients in the general population. And in general, why supporters were quite curious about being able to compare or see how well their patients are doing, they were quite nervous that it didn't really matter so much for what's going on for the individual patient to be able to compare this across a general or more average sort of population statistic. And they were nervous that this might nurture competitive thoughts across supporters and by pressures if, for example, your patients are consistently predicted for worse than the general population. What is that telling you? So this was not something that they were necessarily so fond of. Instead, you know, thinking about how an indicator type insight design embedded within a patient profile, so it would really more about giving context to that person, what's maybe going on for them, was valued much more as a concept going forward. We've had similar responses as well to the idea of a dashboard feedback. So here the idea was, if you can see for each of your patients how they're going to be predicted for, maybe this allows you to prioritize, here are some people who might not get the outcomes needed, who I should prioritize and give more time to. So that was the motivation for this design. But again, concerns were that actually if you see for a lot of your patients that they're predicted not to do well, then that could feel demotivating. What can I really do about this? You know, it might also not be that useful because patients are at different stages of their treatment journey. And, you know, of course, you could see how maybe a supervisor might look at such a dashboard with a supporter and, you know, it could be feeling like a reflection of your performance. You're not generally doing too well across your patients, and that's obviously not a nice feeling either. So that can implicate, so it just shows how the design choices and where you integrate really can implicate even a sense of agency, like how can I achieve change? So quite important. Now, so what ultimately was the most desired design was something that actually turned out to be a very simple visual indicator, where the prediction is just basically just shown at a glance. I should say this is basically what it is, the prediction for PHQ and GAT. Very simple visual indicator, very little text. So something that you really quite quickly could grasp at a glance, and then you could expand on to learn more. And I should say that these supporters are under a lot of time constraints. They have only 15 minutes to review and respond technically to each patient, which is not very much at all. And people had different preferences as well as to how information is being shown, but some get quite hung up, for example, on percentage numbers and confidence intervals. So it could be quite difficult sometimes to understand what's the difference between 83% and 57% confidence in model prediction? Well, probably it's not probably very meaningful, but you could try and figure out or spend a lot of time reading into the details of numbers. So this is why this design has stayed away from numerical detail. But if you wanted it, there is an information box that gives you that clearer insights to just cater for different information preferences as well. In general, there was a tendency to try not to overwhelm with too much detail up front. So any context information, for example, what the prediction is, how the model was derived, etc., was all accessible on demand. So really very much designed around progressive disclosure, like have the main information up front and anything more will unfold over time if you need to. But obviously having a focus on something simple and digestible at a glance means there's less scope to have additional explanations of what the model is or what the limitations might be or whether you can trust the outcome of the AI or not. And that presents a little bit of an issue in terms of you might overtrust the outcome because you can't question it so much. So there is a field within research that is called explainable AI, where you basically explain the workings of the model to kind of help people understand and adjust, could I trust it or not? But actually it assumes quite a bit of technical expertise, you know, and that clinicians are interested to understand the workings of the model and whether they can trust it in the moment or not. When we're in a time-constrained environment, maybe it's an emotional stressful day, you know, you might not want to pause or reflect much about the data prediction itself. It's sort of more a take it or leave it situation. But that can amplify sort of tendencies to over-trust and uncritically accept the data as is, where maybe supporters take the prediction as a shortcut in decision-making. Hey, I need to move this patient on, the AI said so, and might lead them to disregard other important patient information, considerations that the AI can be wrong as well. And so I'm going to touch on 3 sort of mitigation strategies that came about through this work. So one way in which we've been thinking about mitigating this risk of over-reliance on the AI is to kind of embed the AI insight within the patient profile. So here's all the other information that a supporter might have on the patient. Here's sort of above it, the prediction outcome. And so, yes, it's ultimately a binary indicator, but you can balance it with other assessments and information that you have about the person, right? And so in embedding it alongside all these other details, supporters can basically triangulate whether the prediction makes sense given all else they know about the person. So that's one way of inviting a bit more caution. But we should also not underestimate is the power of onboarding prior to any user interface interaction. So how are we thinking about training healthcare professionals when we first introduce any tooling to them on how it works, how the model is trained, how it's intended to be used? this can have huge implications on user trust. So, for example, in our study, we learned that these supporters really appreciated the fact that the model was trained not just on large-scale data, but this data was really quite relevant. I mean, 46,000 previous Silver Cloud users using the same program. That seemed quite a substantial amount to them. Plus, they had a really strong belief in Silver Cloud as a trusted provider that they had been working with for quite some time. And so they felt they could trust that Silver Cloud would do the right thing if they choose to implement such a tool within the service, for better or worse, right? But the trust gets sort of nurtured and created in lots of different ways, the same way that we trust in, hey, there's been clinical trials showing the effectiveness of the AI. There's huge implications, not just about in-the-moment decision-making. Yeah, so I think what is important, perhaps, is how we communicate within training, what the limitations are. And oftentimes, this gets communicated through quite conventional AI performance metrics, like age, accuracy in general, what might be different error types and matrices of that. It's not terribly accessible, I don't think, at all times. We can probably do a little bit better with that. And also work more towards maybe giving examples of what a failure case look like, to then invite discussions of what would be the implications of these different error types on patient, care providers, service resource planning, and so forth. So making that a little bit more accessible, engaged, and grounded in the experiences that people might be having, I think is key here. And then as a third point, yeah, I think there's an interesting element here that this AI tooling does not exist necessarily in a vacuum. So when we talk to supporters, we learned that they're being supervised and guided in their practice, where they learn, especially in this online format, where they already have a data dashboard that already shows different data items, including clinical questionnaires that come with their own limitations and reducing basically someone's mental health to a score, that they learn in supervision how to appropriately interpret these types of data and be reminded about the importance of individualized care, whereby the person, has, a potentially very complex individual mental health experience that isn't accurately captured in a PHQ-9 score or a GAP score, and neither in an AI insight. That is a flag, ultimately a binary flag to say improves, doesn't improve. So I think there's a nice way to think about how thinking about AI adoption as part of these existing practices, and how all sort of data formats have their own unique values, but also limitations, might be a nice way to think about teaching appropriate uses of AI. And I think it's particularly important for AI use where there's a strong focus on just reading a lot into data. There's a lot of critique on risks of dehumanizing in healthcare, where you could argue, health services are already overemphasizing on outcomes, success metrics, and in machine learning even more so. There's a risk of treating humans as just data points and categorizing them into different boxes and so forth, to kind of making sure that the emphasis ultimately is still on the person that is being supported. So yeah, these were just a few insights from this work. We've got a paper here that gives a lot more context and design detail if you're interested. And just to say, the learnings from the study then, outside of the original research collaboration, was taken forward by the UX team at Silver Cloud, who were able to develop a proper first user interface design. They then run a pilot of a fully working implementation. And that was then followed up by a large RCT trial that was recently completed. And that study in particular focused on clinical effectiveness metrics, but also a little bit on learnings about AI impact on workflow adaptations. Yeah, with that, I just wanted to thank the team. This is just the core team, but many others have been involved along the way. And that's it. Thank you.